Today's math lesson is 4.8. We're going to be practicing multiplying whole numbers and decimals together. Make sure you have out an aqua color, it's a blue-green, and a violet purple. Get your journal set up like this and push pause on the video until you are done. So instead of writing out each step and having a lot of details, we are just going to shorten the steps because this is the second day that we will, we've actually been doing this for quite a few days, but this is the day when we're going to put all of our multiplication skills to use. So let's go ahead and write the steps off to the side. So we're going to go ahead and write step number 1. The very first thing you're going to do with this is you are going to do a decimal box. So on number 1, write decimal box. I also think it's a good idea to draw the decimal box. Let's make the decimal box this blue-green color. All right, you're going to write step number 2. The second thing you're going to do is you're going to deal with the zeros. Let's make those zeros purple. Remember, when you're thinking about zeros, you're trying to look for, are there any zeros out in front? And if there are, then they're a runt. Remember that? You're going to have, let's just go ahead and we'll put little dashes underneath here. There's going to be 3 dashes. If the zeros are out in front and there's nothing else to the left-hand side of them, then it is a runt, and you cross it out. Okay? I think the thing I want to draw for cross out is actually not the X. It's actually just going to be a slash, and we'll put that with purple. So if there's zeros out there, we're just going to slash them out. If there's a zero at the end, if you remember, it's a friend, and you move it into your answer. So move down into answer. Okay? And then if the zero is in the middle, it's tight as a fiddle. Or you can say stuck. And it just, leave it alone, basically. You have to leave it alone. You can't do anything with it. So that's what the 3 things that might happen with zeros. Okay, go ahead and write step number 3. Step number 3 is just to do the multiplication. Let's go ahead and put that multiplication in the aqua color. And then get ready to write step number 4. Step number 4 is to plunk or flunk. So I actually think before we move on to step number 4, we should come back to number 3 and we should write, with the multiplication, you may need to rewrite the problem so the longer one is on top. Again, we're writing, you may need to rewrite the problem so that the longer one is on top. I'm going to change that to number. You may need to rewrite the problem so the longer number is on top. That's when we write the big RW, if you remember doing that from last time. So we're just going to write an RW. It just means rewrite it. When you rewrite it, don't forget to do the decimal box that you had from before, and all the same rules apply. But you're just going to commute. You can use the commutative property to change the order of those 2 numbers. All right, step number 4. When you're dealing with whole numbers and decimals, you're going to get into step number 4. In step number 4, I'm just going to say plunk or flunk. The reason why I'm going to say that and put it in quotation marks, plunk or flunk, the reason why we're going to say this is because you're doing multi-digits by multi-digit. So it's not going to be super easy anymore. You're going to have to go into the next place value. So you're going to be doing moving to other place values. That's what plunk or flunk means. It also can mean, have you ever heard of, I'm sure you've heard of, like you place the X, maybe you've done it with an X before, but we've done this a lot of times. It means you're gonna get partial products that you add together. So we're gonna write partial products. Then add together. Partial products, then add together. So far, we first draw a decimal box. We deal with zeros. We then may need to rewrite it, and if not, then we just go ahead and multiply. Then we plunk or flunk because we're going to be doing multi-digit numbers. And then on step number 5, you have to remember to move the decimal into the answer. So we're going to say use the decimal box to put the decimal in the right place in the answer. Use the decimal box to put the decimal in the correct place in your answer. So again, that says use the decimal box to put the decimal in the correct place in your answer. I want you to go back through all of these 5 steps and make sure that you have circled all of them. I haven't, as you can see on my steps 1, 2, and 3. So I'm going to go back and circle all of these, and I'm going to circle them just in pencil. But then I'm going to come up to the box that has steps in it, and I'm going to outline that in purple. So there are 5 steps when we're solving these types of problems. Let's go ahead and solve one over here to the right and see if we can follow all of these steps. The first one we're going to try is, let's do 2.05 times 1.5. Remember, decimals don't line up when you're multiplying. When you're adding and subtracting, they do. So again, the problem is 2.05 times 1.5. Step number 1 is to draw the decimal box. So draw it off to the side and count the place values after the decimals so that you know what number goes inside of that box. Outline that box in aqua blue. And let's see if you and I both put the same number in that decimal box. If you put a 3 in the decimal box, you are correct because there were 2 place values after the decimal on the top and 2 place values after the and 1 place value after the decimal in the bottom number. So again, the top number, there are 2 place values, and in the bottom number, there is 1 place value after the decimal. So it gives us a total of 3 places we have to put the decimal back in. Okay, step number 2 is to deal with the zeros. Are there any zeros in this problem? There are. There is 1, and it is in the middle, so it's tight as a fiddle. You can't do anything with it. Okay, so step number 3, do we need to rewrite this problem? No, because the 2.05 is longer than the 1.5, so I don't need to rewrite it. So I'm on to step number, I just multiply. So it's kind of like I'm doing 205 times 15. That's kind of what that means because of that 3 in the decimal box. I just kind of took away the decimals, and I'm doing 205 times 15. Then I'll put the decimals back in. So I start over in the right, which is the ones, which I guess it's not the ones place technically, but it's the smallest place value on the right. And 5 times 5 is 25, so I drop the 5 and carry the 2. Then I have 5 times 0, and that's 0, but then I have to add 2, and that's 2. Then I'm doing 5 times 2, and that's 10. And there's nowhere to carry, you drop the 0, and then there's nowhere to carry the 1 because you're out of place value, so you just put it in the answer. So my first partial product should be 1, 0, 2, 5. And now when I'm moving on to the next thing, I cross out the numbers that I no longer need. I don't need the 5 in the bottom right corner. And I don't need that little 2 because I'm not adding that anymore. And I'm moving on to the next place value, which means, look at step number 4, plunk or flunk. You have to put a 0 there. In fact, let's place a 0 there. We're going to plunk or flunk with the aqua blue 0. So you put an aqua blue 0 on step number 4 like that, and then come over into the problem we're working on and put that aqua blue 0 below the 5. Because I'm moving on to the next place value. So I plunked that 0 down. Now I move on. 1 times 5 is 5. 1 times 0 is 0. And 1 times 2 is 2. So I have another partial product of 2, 0, 5, 0. So what do I do with those partial products? I add them together. So I put the plus sign and the equals bar, and I begin on the right to add them together. When you get done, see if your answer is the same as mine. You should have 3075. And step number 5, use the decimal box. Oh, I don't like that in step number 5, we didn't draw what that looks like. So draw the decimal box, outline it in aqua blue, and we're going to draw an arrow kind of down to what we have to do. Kind of works like that, little squiggly arrow. Okay, so let's go back up to our problem and do that same thing. Make sure the box is aqua blue and then move the arrow down into the answer line. Because this wouldn't make sense if you said the answer was 3,000. If you did 2 times 1 and a little more, it shouldn't be 3,000. So move the decimal 3 places, beginning right here. It automatically would be at the end of the 5. So now you move it 3 places to the left. So 1 place would be in front of the 5, 2 places would be in front of the 7, and 3 places would be in front of the 0. So it belongs in between the 3 and the 0. As I go to circle my final answer, I'm going to use purple, I'm going to make sure that that makes sense. Could 3 be a product of 2 times 1 plus a little more? Yeah, it could. So my answer to that problem is 3.075. Do you see how different a decimal makes? It was 3,000 before we put that decimal back in. So decimals are critical. Make sure you are doing the decimal box and that you are drawing the arrow into your answer like you're supposed to be. All right, let's try another problem. The next one I want to do is, let's do 0.3. Actually, I don't want to do that one quite yet. Sorry. 4.2 times 8.1. We're just going to do it over here to the right. So again, the problem is 4.2 times 8.1. Okay, so I draw a decimal box over in the top right corner. I put the number that goes in that decimal box, and I'm going to also outline it in the blue. The number that goes in the decimal box is 2, because there's 1 place value in the top number after the decimal, and 1 place value in the bottom number after the decimal. So when I put the 2 over here, it's like taking the decimals away and saying, okay, now I'm doing 42 times 81. So, are there any zeros? No, I'm already past step number 2. Step 3, multiply. Do I need to rewrite it? No, they both have 2 digits. 4.2 has 2 digits and 8.1 has 2 digits. So I just multiply. So I start in the bottom right corner at the 1. I'm going to multiply up and then across. 1 times 2 is 2. 1 times 4 is 4. There's no more digits to multiply the 1 by, so I'm done, and I need to plunk or flunk. So I place the 0 where it belongs. I'm going to cross out any numbers that aren't necessary anymore. The only one I get to cross out is the 1, so cross out the 1. Okay, now I'm moving on. I've got my first partial product. Now I'm moving on to the 8, and I go across and then up above. So 8 times 2 is 16. I drop the 6 and carry the 1. Remember when I say to carry the 1, we're carrying it into our factors up above. So I don't put it in front of the 6. I've got to carry it over into the factors. So 8 times 2 is 16. I drop the 6 and carry the 1 above the 4. Now I do 8 times 4, which is 32, plus 1 is 33. So I have another partial product. And what do I do to these two partial products? I add them together. Will you please add your partial products together and see if we get the same answer? Your answer is correct if all of the digits add up to be 9 in the answer. Okay, the answer is 3402. Those are the digits of the answer. But if I'm doing 4 times 8 plus a little more, it can't be 3,000. You know that 4 times 8 is 32. So it's going to be a little more than 32. I really need you to start thinking through the logic of these problems. And one last thing we have to do on step number 5, we've got to draw that decimal box arrow. So draw it from the box down into the answer and move it to place values. It should go then in between the 4 and the 0. Does 34.02 make sense? Yes, so I circle it in purple. And that is a logical answer because 4 times 8 is 32, plus it would be a little more because you had extra pieces you were multiplying. So that one did make sense again. Okay, let's try the next problem. We are going to be doing the next problem under step number 5, so slide your journal down and get ready for a little bit of a more complicated problem. And we're going to see how we do with this. You ready? The problem is 0.3 times 1.52. Again, the problem is 0.3 times 1.52. That's what the problem looks like. So I begin with step number 1, which is to draw a decimal box. So draw a decimal box up to the right. And what number goes in that decimal box? Make it blue. Well, the number that goes in that decimal box is 3. Did you see how it was 3? If you didn't, come talk to me so I can give you some help. Okay, so now I deal with zeros. There is a 0 out in front of the 0.3. So I get to take my purple and slash it out. It's a runt. Goodbye. I don't really need you. So now it's just 3 times 152, or 0.3 times 1.52. So on step number 3, do we need to rewrite the problem? Yes, we do, because the longer one was not on top. So with the blue color, we are going to do it like this. We're going to do a capital R, capital W, and we're going to rewrite the problem, which puts the longer one on top. So you have to rewrite the whole thing, the digits and the decimal box. So 1.52 times 0.3. You had a decimal box. It had a 3. You also got to slash out one of the zeros. Well, the only 0 there. So the problem now looks like 1.52 times 0.3. Do you know what property that is that lets us rewrite it? I'm going to write it. It's commutative. Commutative. You should write it as well. That is the mathematical property that lets you change the order of the numbers. Remember, it only works with addition and multiplication. In this case, we're using it for multiplication. So let's go back to our problem. We have 1.52 times 0.3. Well, when we put the decimal box out there, it's like we're saying 152 times 3. So this shouldn't be too bad now that we've rewritten it. We need to multiply. We're not even going to have to do step 4 because it's a 3-digit by a 1-digit. So that's cool. Okay, start in the bottom right. 3 times 2 is 6. 3 times 5 is 15. Drop the 5 and carry the 1. 3 times 1 is 3 plus another one is 4. So I don't have partial products in this case. I have one product. This does not make sense. How could it be 456? What I'm doing is I'm taking a piece, because that's a decimal, 0.3. I'm taking a piece of 1.5. It cannot be 456. That's why you have to have step number 5. It is critical. Draw the arrow from the decimal box into the answer line. And move that decimal 3 places. It comes out in front of the 4, which means you need another 0. And that makes more sense. A piece of 1.5 could be 0.456. So decimals are critical. I hope you're catching on to that. They are critical. Let's try one more over here on the right-hand side. If you don't have any space in your journal, you're going to have to be really creative about where you put it because I don't want you to turn the page yet. All right. Let's move on and let's try one that's a pretty interesting problem. This one will be a good one. 9.9, actually, yeah, it's a big one. 9.9 times 6.6. Just gonna do it right here. 9.9 times 6.6. Draw the decimal box. And why don't you try doing this problem completely on your own and come back in a second. Don't push pause in the video. I'll leave some time for you, but solve the problem and come back and see if we all get the same answer. I'm going to freeze mine. Don't forget the decimal box. That's critical. Get all the way to the end, and if you're confident, circle it in purple. So you should be working on this problem, putting a number in the decimal box, checking for zeros, doing the multiplication, double checking to see if you need to rewrite it, understanding this is a plunk or flunk. You're going to have a 0 to get partial products. Good luck. Scratch out the things you don't need. Will you use your blue for that 0 that's getting put in there for place value? You should have your 2 partial products by this point. They look really similar. One of them just has a 0 at the end. And add your partial products together. And think through your answer before you circle it. Can it really be that big of an answer? Use your decimal box. And only circle it if you're confident. Go back and look at what the factors were. See if it makes sense. It should be 9 times 6. Well, really, 9.9 is really close to 10. So it should be about 10 times 6 and a little more. Or you could even do 9 times 6 and a little more. Double check your math. I'm double checking mine. Okay, your answer is correct if it has the digits 3, 4, 5, 6, but they're not in that order. Your answer is correct if the decimal goes right in the middle of all the numbers. So it's 2 numbers, then a decimal, then 2 numbers. Okay, you ready for me to unveil the answer? The answer is 65.34. That makes sense because 9 times 6 is 54, and it would be a little more. And 65 is 6,000 wouldn't be. That's why I had you double check your answer and think through what your decimal was doing for you. Okay. what we're going to be doing on the next journal page, you are going to need your workbook for. So I'm just going to have you get this out. We're going to be, on the next video, we're just going to be solving some real world problems because we've done all the steps and we've done several practice problems. So I'll just show you what page you need to get and then start the next video after you get this page. Tear out of your workbook this page that says Unit 4, Lesson 8, Practice Multiplying Decimal Numbers Greater than 1. But this will help you a lot easier. It's just page 167. Go ahead and get out page 167, and I'll catch you in the next video.